Hello guys, so in today's video we are going to discuss the solution of a Leetcode problem, maximum of absolute value expression. So in this problem, let us first understand the problem statement. So we are given two arrays of integers with equal length. Return the maximum value of this expression. Okay, so we are given two arrays, array 1 and array 2, and the length of these two arrays are same, and the objective is to maximize the value of the expression, this particular expression, which is ar1 of I minus ar1 of j plus ar2 of I minus ar2 of j plus I minus j. Okay, so let us let us try to understand the problem statement further and try to work on the solution for it. Okay, so the problem statement basically says is we are given an array, two arrays, array 1 A and B. Let us say we are given two arrays A and B, and the objective is to maximize what do we want to maximize is basically A of I minus A of j plus B of I minus B of j plus I minus j. So there are the modulo functions. So the brute force solution is possible here, and the brute force solution is basically for all I and j, compute the values, compute the value of the expression, right? And while computing, find the maximum value, right? So we'll keep on computing the for all I and j, we will keep on computing these values, and so we'll have value 1, value 2, value 3, and so on, and then we will find the maximum of these values. So the max of. So this is the brute force solution. I'm not discussing it in great detail because this is not the so basically the running time complexity of this solution is O(n) square, and this is a costly operation, and there are better ways of solving this problem. So we will focus on the optimal solution more rather than the brute force solution. So let us look at the optimal solution now. Okay, so let us look at our expression. So our expression was basically we wanted to maximize AI minus AJ, okay, plus modulus of BI minus BJ plus modulus of I minus J. So we wanted to maximize it. Okay, so let us do this. Let us first divide this expression into three parts. So this part, let us call this part as X, this part as Y, and this part as Z. So what I essentially trying to say here is that let us say X is equals to modulo of AI minus AJ, okay, Y is equals to BI minus BJ, modulus of course, and Z equals to modulus of I minus J. All right. So now let us also understand the meaning of modular operation. So we know that basically this is, I'm just writing it down here, like mod A is equals to A if A is greater than or equals to 0, minus A if A is less than 0. So for instance, minus 3, if you want to compute it, so minus 3 is what? Minus of a, so minus of 3, which will be 3. Similarly, 3, if you want to calculate, this will be just 3. So this is what the definition of modulo operation is. Now let us plug these the definition and try to expand this particular expression. Okay, so when we try to expand this expression, so this could be, so this could be either greater than 0 or less than 0, right? It could be either greater than 0 or less than 0. Similarly, y could be greater than 0. So basically y could be positive or y could be negative, right? So let me write it down. It could be positive or negative, and similarly z could be positive or negative, right? So here also x could be positive or negative, the resultant of x. Okay, so on that grounds we can split or we can expand the equation into 8 different forms. So our case 1 would be where a is greater than 0, b is greater, sorry, not a, we have considered it as x, so let us use x. X is greater than 0, y is greater than 0, and z is greater than 0. Okay, so what will happen in this particular case? Case 2 could be x is greater than 0 and y is greater than 0 and z is less than 0. Okay, this is okay. Let me just write it down. Z is greater than 0. All right. So similarly, all the cases, let us write it down. So case 3 would be x is greater than 0 and y is less than 0 and z is greater than 0. All right. Similarly, case 4 would be x is greater than 0, y is less than 0 and z is less than 0. Okay, let me take a next page here, just a second. Okay, so far we have added 4 cases. Let us add the 5th case. So the 5th case says is basically x is less than 0, y is greater than 0 and z is greater than 0, right? 6th case would be x is less than 0, y is greater than 0 and z is less than 0, right? 7th case, okay, 7th case, x is less than 0, y is less than 0 and c is greater than 0. And the final, which is the 8th case, is basically x is less than 0, y is less than 0 and c is also less than 0. Okay, so now let us plug the, so when, like we understand that when a is greater than 0, then the mod of a will be a, and when a is less than 0, the mod of a will be negative a. So let us use that and expand this. So remember, we want to basically, so we have replaced, so this x is equals to this, y equals to this, and z is equals to this. So the expression essentially translates to x plus y plus z. Okay, now let us use x plus y plus z and expand it on the basis of the cases we have written. So here it says x is greater than 0, y is greater than 0, z is greater than 0. So this will be equals to, let me use a different ink. This will be equals to x plus y plus z, right? And this, if we say, this will be equals to x plus y, and since z is less than 0, so this will be minus z. All right. This will translate to what? X minus y plus z. Okay. And this will be equals to x minus y minus z. Okay. Now let us expand this. This will be equals to minus x plus y and plus z. So let us rewrite it. We can take minus s common, and this will becomes x minus y minus z, right? And this will be equals to minus x, okay, let me just plus y minus z, right? Let's take minus common, so x minus y plus z. Okay. This is basically minus x minus y plus z, and if we take minus common, this becomes x plus y minus z. Similarly, this is minus x minus y minus z. If we take minus common, this becomes x plus y plus z. Alright. So now let us compare all the cases. Okay. So let us compare case 8, the value of negative of x plus y plus z, and let us compare it with case 1. Case 1 is basically x plus y plus z. So case 1 and case 8 are same with an exception that case 8 has minus. So negative is there, negative of x plus y plus z, right? But if you see this, and similarly if you look at other expressions, so case 2 for instance, x plus y minus z, and case 7 if you see, so that is also minus x plus y minus z. So case 7 and case 2 are the same with an exception of the negative sign, we have taken it out. Okay, but in theory, but in practice when we'll use it, so case 1 is equivalent to case 8. Okay, similarly case 2 is equivalent to case 7, case 3 is equivalent to case 6, and case 4 is equivalent to case 5. We will discuss it, uh, but you get the gist. So the point I'm trying to make here is that, so essentially we had to first compute all these 8 cases, but since the case 1 is equivalent to case 8 and so on, case 2 is equivalent to case 7, thereby we don't really have to compute all the 8 cases. We can just focus on the 4 cases, which is this case, this case, this and this case. And once we solve these 4 cases, we want to find the maximum value of these cases, and the maximum value will be the answer to our problem statement. Okay. Okay, so let us revisit this when we are saying that case 1 and case 8 are same. Okay, to solve this, to understand this, let us expand case 1 bit further. Okay, so case 1 is basically x plus y plus z, and x is, as we know, is ai minus aj. So let us use it, ai minus aj. Okay, I am expanding it, ai minus aj, y is bi minus bj, and z is I minus j. So let us rearrange it. So basically I want to write all I terms together and j terms together plus I. Okay, and this is one term, and let's take the jth term common, so aj, and this will be bj plus j, right? Okay, so this is how case 1 will be expanded to. All right, now look at case 8. Let us look at case 8. So case 8, I'm writing it over here. So case 8 is basically case 1 with a negative sign. So let us just write the case 1 and we will put a negative sign there. So this is the case 1. This is the evaluation of case 1 and with a negative sign. So let us write the here, and we will say this is basically ai plus bi plus I minus, okay, aj bj plus j. Okay, so essentially we can write it down if we expand it further. So this becomes aj plus bj plus j minus, so I'm writing this term here and this term here, right, and the negative sign, this becomes plus and so on. ai plus bi plus I, right? This will be there. Okay, so this is case 8 and the first one was case 1. Now let us look at the expression. So if I want to maximize the value of C8, so this is our case 8, right? If I want to maximize its value, so let me denote it by green. So if I want to maximize it, so basically I want to maximize this, then I have to maximize this term. So I have to maximize this term and I have to minimize this term. Okay. So basically what I'm trying to say here is in array A and in array B, I'll find the using array A, B and J, which is the index. I'll compute all the, for all elements, I'll compute the value of the expression AJ plus BJ plus J, which will give me various values, right, for all J. Okay, let me use a different ink here. So for all J, we will evaluate AJ plus BJ plus J, right? So let us say this is represented, let me use this, right, maximized one. This is one set and there will be various values to it, v1, v2, v3, v4 and so on, right? So like v1 is basically, what I'm trying to say is that v1 is basically a1 plus b1 plus 1, j is 1, right? Similarly v3, for instance, v3 is a3 plus b3 plus 3, right? So we will compute all the values and we will find the maximum here. Okay, so we'll find the, so let us call this set as, you know, some set, let us call it as S, right? Okay, and when we want to maximize this value, right, this one, so what we have to find out is the maximum of set S, right? And when we try to, so see this also is the same set, right? We have already computed the values of v1, v2, v3, v4, right? Let me just write it down as 4, and from here we will find the minimum value of the same set S, right? So case 8 basically translated to, right, let me just rewrite it, case 8, okay, let me use the same thing, case 8 basically translates to maximum of set S minus minimum of set S, right? That is one way of interpreting it or one way of understanding it, right? So this is my case 8. Okay, now let us look at case 1. Okay, let me use a separate page for this. So case 1, what was the value of case 1? So case 1 is basically, let's go up, and case 1 is basically summation of ith term and summation of jth term, right, and the difference between it. So let me just write it down, ai plus bi plus I minus aj, bj and j, right? So again, this also we are computing the same thing. Remember, the set S, right, this set S contains all the values which can be obtained by solving this expression, right? So again, when we try to maximize the value of case 1, right, we will try to maximize this, which means we want to find the maximum value in the set S, and we will try to minimize the value here. So we will try to find the minimum value here. So essentially case 1 also translates to maximum of S minus minimum of S, right? Hence we can safely say that C1 is equivalent to C8, right? C1 is equivalent to C8. Okay, I hope that makes sense. And similarly, we can say that case 2 is equivalent to case 7, case 3 is equivalent to case 6, and case 4 is equivalent to case 5. All right. Okay. Okay, so if this is not clear, let us take an example and let us try to understand it. What do I mean by this? So let me go back to the problem statement. Okay, and let us just take the example from there. So the example is basically, what is the example? So 1, 2, 3, 4. Okay, 1, 2, 3, 4, and we have -1, 4, 5, and 6. All right. Okay. Let me switch to my journals. Yeah. Okay. Now we have what? Set A as 1, 2, 3, and 4, and array B is equals to -1, 4, 5, and 6. Okay, so let us write it down. So essentially, so this is the index here. Okay, so 0 index, first index, second index, and third index. All right, and here let us say this basically is AI plus BI plus I, right? And here we want, okay, so it's the same thing, right? Here if you see AI BI plus I, and here also AJ BJ plus J, right? So let us now look at this. Okay, so let us do this. AI plus BI plus I. So I, for I equals to 0, AI is A0 is 1, 1 plus -1 is 0, and then 0. So this is 0. Similarly, 2 plus 4, okay, 6. 6 plus 1 is 7. And 3 plus 5 is 8. 8 plus 2 is 10. And 6 plus 4 is 10. And 10 plus 3 is 13. Right? So now let us evaluate C1. Let us evaluate C1 and C8. So C1, remember, I want to find the maximum, and this is our set S, by the way. So we want to find the maximum of C1 and minimum of maximum of in set S and minimum in set S, and we want to take a difference between them. So like this is the maximum is 13. Let me use a different color here. So this is 13, and the minimum is what? Minimum is 0. So the C1 will result into what? 13 minus 0, which is 13. And let us try to evaluate using C8. So C8 is also the same thing. We want to find the maximum and minimum in the set S, and that also will give you the same result. And that is why we are saying that C1 is equivalent to C8. By the way, guys, this is not the answer. We have just computed C1 and C8. We also need to compute C2, C3, and C4. The answer is basically max of C1, C2, C3, and C4. Okay. All right. So that's pretty much it about the explanation. Let me jump to the coding section and let us code this one. Code this. Code the solution for this condition. Okay. So let me switch to my this. Okay. All right. Okay. So we are given this and two arrays AR1 and AR2, So let us take max. So remember, we want to take maximum one, which is like, so let us initialize it. Start max size minus one. So this is basically negative infinity, and min one, which is equals to start max size. This is positive infinity, and let me. Okay, let's max 2, min 2, right? 3, but oh, I have not computed the equation. So let me first find out the equation. I'm sorry, this is 4. Right, so remember we discussed this, and at that time we were saying that our solution will be done by just evaluating the 4 expression, which is C1, C2, C3 and C4. Well, C1 expression we have evaluated it, and the C1 expression is there, but C2, C3 and C4 expressions are yet to be evaluated. So let us first evaluate it and find the equation for it. So what is C2? So C2 is basically x plus y minus z. So let us plug the values of x plus y minus z. And if we plug the values, what we will get is basically, so I'm just writing it down straightforwardly, AI, so this is A plus BI minus I, okay, and similarly A of J plus B of J minus J, okay. Similarly, if you expand C3, C3 will be basically it will be A of I minus B of I plus I minus, what is this, A of J minus B of J plus J, okay. And the fourth is basically, so let us write it down here, is basically A of I minus B of I minus I, and this is equals to A of J minus B of J minus J, okay. So now let us go. So we essentially got our 4 equations. So this is the expression 1, this is the expression 2, this is expression 3, and this is expression 4. So we will compute these 4 expressions, the values of these 4 expressions for a given I or j, and then we will find the maximum of these 4 expression, and then that will be our answer. Okay, so let me just switch to our coding section. Okay, just a minute. Okay, now let's see. So that is why I have used those 4 variables, which is max1, max2, max3 and max4, and min1, min2, min3 and min4. These variables, okay, let me just go there to explain it. So basically, if you see this equation, here I wanted to maximize this term. So this is something which is represented by max1, and I wanted to minimize this term. So this is something which is represented by min1. Similarly, this is my max2, min2, and max3, min3, and max4 and min4. Okay, so that is how this goes. Okay, now let us switch back to our coding section. So now let us see. So once we have all these four set of variables there, now what we can do is that, let us say I equals to 0, and while I is, let us iterate on the AR1, length of AR1, and since the length of AR1 is equals to length of AR2, so we don't even have to worry about AR2 here. Now let us evaluate the expression. So val1 is basically equals to, what was our expression? Let us switch back to our expression just to see the values. So here, so the first expression was this, and the values is ai, bi, the summation of ai, bi, and I. Okay, so let me go here. So value is arr1i plus arr2i plus I, right? Similarly, value 2 is equals to, basically, so it's the same thing. From the equation I'm taking it up. I'm not switching back and forth. I'm just directly writing it now, which is equals to arr1i plus arr2i minus I. Okay. Val 3 is equals to arr1i minus arr2i plus I. Okay. And val 4 is equals to arr1i minus arr2i minus I. Okay. So these are the four values which we have, and we have to find the maximum and minimum. So let us update the max1. So basically max1 is equals to max of max1 or val1, and we wanted to minimize also, right? So this is min1 is equals to, want to find the minimum values here. So min1 and value, right? So let us just go back. What I'm doing here is basically, so I have evaluated the expression. So the values are there in the set S. So this is what is forming set S, and the values goes into set S, and I'm trying to find the maximum and the minimum value in the set S. So this is what finding out the maximum and minimum value in the set S is. Okay, so let us do it for other sets also. So this will be 2, 2, and 2, 2, 2, and 2. Let's do it for the third one. 3, 3, 3. Let's do it for the fourth one. 4, 4, 4. Okay. All right. So, okay, by end of the loop, we'll have the values with us, right? And let us now find the C1. Like for case 1, what is the maximum value we obtained? So for case 1, the maximum value is basically max 1 minus min 1, right? Similarly for case 2, it is equals to, let me just copy paste it, max 2 minus min 2, all right? And for case 3, this is basically 3. And for case 4, this is what is case 4, right? Now once we have case 4, so we want to find the maximum value. Okay, so let us write down a function here to find the maximum between 3 element. So a comma, given 3 elements, let us write the code that this function basically from 3 element, it gives you the maximum value. So if a is greater than b, then return max of, right, a comma c, else return max of b comma c, right? So that is how this thing is there, and let's do this. So max 1 is equals to self dot maximum, and let's pass the values here, c1, c2, and c3. So the maximum of c1, c2, c3 is what? is something which is there in max1, and now just return the max of max1 comma c4, right? All right, so let us try to run it. Oh, okay, sorry, I think I am not incrementing the index, which is so it will end up into an infinite loop and it will create a problem. Okay, yeah, so let me now run it. All right, so this got accepted. Now let's submit the solution. Okay, so very well, guys. So this got accepted, and that's it, guys. So this is the code for it, and that's the explanation. In case if you have any issues or any problem, please feel free to drop a comment, and I'll try to visit it. Thank you very much.